Hello, everybody, and welcome to the Modern App Dev webinar series with AWS. Today, we're going to be talking about Modern App Dev on AWS. My name is Curtis Reese. I'm a Senior Solutions Architect with AWS, or Amazon Web Services. Today, I am joined by the wonderful Tolga Tarhan, the CTO of Premier Partner Onica.
Hi, guys. My name is Tolga. Thanks, Curtis, for that intro. Today, we're going to talk about legacy versus modern apps and both the technology and the process and culture elements of this sort of cloud-native world. We'll talk about the path to get there, and then we'll go through a couple of customer case studies as well.
Awesome. Before we dive too deep in, let's go ahead and start with some level setting and talk about some of the ways legacy applications work and some of the challenges that we typically see around legacy application development. In the context of a legacy application, what we're typically referring to is something like a monolith application where everything is all within that one code base. It's probably run in a more waterfall approach where there's these longer release cycles, multiple features, and it takes a much longer time to actually get a feature out to production. And once it's in production, because it takes a long period of time, there's some operational issues around things like scaling that application either up or out, identifying and fixing bugs. It takes a much longer time to get them in at least one release cycle. It might even take a couple of release cycles to try and drive out bugs. And what this really equates to is that over time, you build up a lot of technical debt, which can degrade the software and make it worse over time. And so what would comprise a modern application architecture, and how would it actually provide more value over this legacy kind of model? Well, if any of you have heard of things like microservices, this is one approach to a modern app dev or a modern application architecture. So in a microservice environment, it's composed of these smaller, more independent services that do one thing and do one thing really well, and they communicate with each other over well-defined and often versioned APIs. So each developer, each team of developers at AWS, we call these two pizza teams, where they're a smaller team of developers that could be fed by basically two pizzas. I mean, each of these teams basically identifies a code base that they want to work on. They're going to choose a code language that's specific to that code base that they want to do. And I don't like that. Back that up. So each team is going to basically be a much smaller team. They're going to be comprised of what we at Amazon call a two pizza team. So that's a small enough team that it can be fed by two pizzas. And each team is going to work on their own individual code base. And it can be in a polyglot of languages. It could be one language. But the idea is they work on a smaller code base that does one thing and does one thing really well. And because it's a smaller code base, there's smaller features that have to go into it, or there's fewer features that have to go into it typically. And so this leads to smaller and more frequent updates. And because it's also a smaller code base, it's much easier to scale the application. Imagine if you had a monolithic application that has a login component, a UI front-end component, a back-end component, and you needed to scale just the back-end component. Well, because it's one code base, you're going to have to scale everything all at once. In a microservice-based environment, you're going to have smaller services, and you can scale each of them more independently. And what this also leads to is it allows you to accelerate your development cycle. So as you identify new needs of your customers, or you want new ways to innovate your application, because you can test these things much more quickly, you have a much faster release cycle to achieving benefits to your end customers. We mentioned microservices. Well, there's a couple different ways to handle microservices, or as we're referring to it also as a modern application. One approach is through what we call containers. And containers are essentially a standard method of packaging an application and all of the binaries and libraries that are needed for just that application into a single object or artifact. It makes these things very lightweight. Since it's just what's needed for the application, they can spin up very quickly within seconds. They're usually really small in the megabytes or less, in that kind of a size range. Another option is what we call serverless, where you treat your application or your services as functions, and you operate those functions and write those functions on AWS in the sense of what we call a serverless approach. So there's no servers underneath. So with a container, you basically have a cluster of servers that you have to keep track of, and they will handle the scaling of your containers on top of them. With a serverless approach, there's no servers to manage. You basically write your function, you deploy your functions, and the cloud will actually take it and scale it based off of what it sees as needed. And so how do you approach this? Like, how do you think of them differently? Like, what's the methodology here? Well, the idea is you want to treat development as an iterative process. We want you to start with that. We want you to make more frequent changes, get feedback from users, identify their needs, and keep making those changes. We want you to collaborate to complete tasks earlier. So we call this shifting left. And the idea here is we want you to identify bugs sooner in the process. We want you to identify potential features sooner in the process while developers are working with each other and it's fresh and top of mind. So it's not a cycle of we write code, we get it off to testing, we push it out to production, and we wait and see over a longer period of time. We want to basically move things as close to that left side, that development side as possible. And we want to move security responsibilities towards the beginning of the process as well. So in a typical legacy application model, the way it works is developers write their code, they pass it over to a QA team, a build team, a release team, and then eventually it gets to a security and operations team. And in this new model where it's more real time and we've shortened these cycles, what it requires is everybody to have more of an active role in the security footprint of the application. And so everybody has to understand how their code is secured, how the deployment process works and is secured. And so it means that security is a much more holistic and foundational component throughout. Now, I'll pass it over to Tolga so Tolga can walk you through some of the typical processes we see around each of these types of development.
Great, thanks, Curtis. So let's talk first about how this works prior to this cloud native world. In the past, there was this kind of build first, deploy later methodology. There's a number of issues here. The biggest issue is that the developers working on the code often are unaware of the operational considerations. So things like, how will the application be configured in different environments and be promoted between environments? How will they find credentials to connect to the database? How will they incorporate access to third-party systems? These kinds of things are often simplified in development and become concerns when it's time to go to production, causing almost a second development cycle to just become production ready. So that's sort of the legacy way. That's the way things work oftentimes. And it's the way things work often when you're just using the cloud is an infrastructure as code kind of model. As we move on from this model to more leveraging the cloud as a unique platform, we start to re-platform bits and pieces of this. We start to utilize containers, and we start to switch to RDS for databases. We start to replace appliances with either cloud services or soft appliances. And auto-scaling and self-healing become part of the solution. So this is sort of the mid-step of re-platforming to leverage the stuff that the cloud provides without rewriting our app. The sort of final frontier here is to then go ahead and leverage the cloud as a dev platform. So stop treating the cloud as a place we deploy to and start treating the cloud as a place we develop. To do this, we have to actually consider our design and architecture with the cloud in mind from the beginning, and we have to build to a model where we can rapidly build, test, and deploy all throughout the app lifecycle. So this lends itself very well to microservice architectures that are stateless, that leverage kind of serverless data stores like DynamoDB. And in these models, it's the dev teams that are selecting the services and assembling the infrastructure, not separate ops teams, because the services that are being selected become a fundamental part of how the software operates. So if we visualize these steps, take a look here, and you can see that the top line is what a hypothetical Windows-based app would have looked like in the data center. The compute layer, the web layer, databases, and so on. So a simple migration to the cloud moves all of that to EC2. So it doesn't give us all the value that we're looking for. The re-platforming would be the one layer down where we modernize the low-hanging fruit. We take SQL Server and put it on RDS. We take file servers and put them on S3. We take Active Directory and put it on directory service. But the cloud native approach, what we're talking about here, is that bottom line, where we actually refactor the application to be event-driven and serverless. We use API gateway. We use serverless data stores, and we use, as a result, no servers. So serverless is being adopted very widely today for web applications and backends to mobile and IoT applications. because these things are inherently event-driven. A web request is an event, an IoT message is an event. This works really, really well. It's a very natural workflow. It also works really well for Alexa as an example, where to use the Alexa APIs, you in fact have to implement your business logic in Lambda. Data processing, I would say, is an up-and-coming area for serverless, and we're seeing more and more technology in that space. So let me take you through 2 case studies now, and I'm going to talk about a business problem and a solution and an architecture, and we'll touch on how serverless is leveraged in each of these. So Alistair Group is based in East Africa, and they are solving logistics problems in parts of the world where logistics is less mature. As they built up their operation, they had to build tools and systems to track where trucks and drivers and trailers and other equipment were, or to help figure out the cost of a route, to figure out different laws and regulations that would apply as they transited multiple countries. All of this required building some custom logistics software. So we worked with them to build a cloud-native application. And I'm going to show you the architecture in a minute, and we'll talk about how same microservices are being used to power both a web application and an Android application. And they're used for different workloads. So the web applications are, for example, used to manage the overall operation, whereas the Android applications are used for specific tasks, perhaps in the maintenance yard or perhaps on the truck itself. So this is completely serverless. The only area here where you even remotely see a server would be Elasticsearch, but even there, it's a fully managed service. So let's take a look at the architecture. You can see here there's Lambda in a few different places, but the important takeaway is that it's actually one cohesive application that's comprised of a number of microservices that are servicing both these web and mobile clients over RESTful APIs. So if we're going to load the status of a particular trip, for example, on the web app or on the mobile app, the same exact backend is going to respond to those. And to accomplish this, we need to really separate our backends from our front end. So when we develop serverless apps, we typically develop the backend in an API-first fashion as its own application, and then we build the UIs that we need, and those UIs can be varying forms, varying platforms. They can change over time. You'll also notice the utilization of Dynamo here, and for some capabilities that were beyond what we could do in Dynamo, Elasticsearch. And then finally, even a creative use of IoT Core being used to deliver real-time updates to the web browser. So in this environment, almost nothing needs to be managed from a scale point of view. The only exception would be Elasticsearch. So just to bring that to life, a couple of screenshots. I'm going to just briefly show these. You'll see here the Android app that's being used to see the status of a particular load. Or you can see here the web applications that are being used to monitor the overall status of the drivers or the trips. And again, powered by the same backend infrastructure. So at the end of the day, this customer was able to get all the scale and cost benefits of a serverless approach, because when there are no API calls being made, none of those Lambdas are running. Nothing is happening in the API gateway. There's very little steady state cost. And with a spiky workload that's business hours driven, that can make a big difference. It also enabled developers to have a really simple workflow to continue to enhance the applications and a safe place to build and develop and test. But that safe place is exactly the same as the production environment they're going to promote to. And that enables us to rapidly move from dev to prod without a big step back during that process. Okay, now we're going to talk about a global entertainment venue. And here, let's just talk about sort of a thought experiment on how this problem came to be. So on the absolute smallest scale, we're talking about dispensers that dispense drinks. So take, for example, the iced tea dispenser at any restaurant. They're typically just a big bin full of tea. And when the tea runs out, you brew more tea and you pour it into the big bin. They're pretty low-tech devices. And in a simple restaurant, you would simply have an employee go and check that every 10, 15, 20 minutes, see how much tea is left, and if needed, order more tea. But what happens as we scale up? What happens as we have more than one station where drinks can be filled up? At some point, it becomes ineffective to have people walk out and physically look to determine if more is needed. Also, as you get more sophisticated and a larger venue, it may not be efficient to fill one tank from another. It may be more efficient to just replace the whole tank from a workflow point of view. But that becomes very wasteful if you're doing that before the tank is almost empty. And so let's take a much larger property, something that looks more like these. In these properties, it could take someone the whole day to walk from one end to the other, checking dispensers. And so it's impractical, or I should say ineffective at least, to walk around and do that. So imagine if there were 10,000 of these. And imagine if you had a bunch of non-technical staff that are both filling them, servicing them, cleaning them. How do we optimize all of this with automation, with serverless application? So one more business rule, and I'll show you the solution. We know that currently workers come in and receive their daily assignment every day. And we also know that currently different drinks are in different carts. We want to make sure there's never an empty dispenser. We want to have the fewest possible deliveries. We want the shortest possible route. So given these constraints, how do we build a system that does this? This is going to be a combination of an IoT and serverless strategy. Starting with the IoT part, we had to consider how do we pick the right sensor, which in this case is pretty straightforward. You can use flow rate, you can use weight, you can use laser, time to return. There's lots of ways to measure how much liquid is left. But then we had to solve for connectivity. Are we going to use Wi-Fi or cellular or some other low power network? We had to solve for batteries and how we're going to make batteries last as long as we need, as well as how we're going to make them easy to replace. And then we had to integrate that into sort of a custom design. On the cloud side then, it's important to prevent cloning of devices and ensure that the device you're talking to is who you think it is. It's important to encrypt this data because actually from this data, you can learn a lot about the time and places that guests were spending their time. And we have to deal with some locality and privacy and regulatory issues depending on where we're deploying. At the same time, we have to make sure we can scale for spiky workloads. As you saw those pictures earlier, these kind of properties are probably open certain times of year and certain times of day. And so scaling down all the way to zero is pretty valuable. And then of course, reliability becomes super critical because as this is impacting the guest experience, if the dispensers are empty and people can't fill their cups, then we're going to see a guest experience problem. So here is the architecture. We've got devices in the field talking to IoT core over MQTT over TLS. Then we're using an IoT rule or two IoT rules. We're actually splitting the data stream into two places. We're sending it to S3 via Firehose, and this is data that's then used for analytics. But then for the real-time workflow, we're actually sending data from Kinesis data streams into Lambda functions, and this is where the serverless application comes into play. This serverless application then implements all the business logic that you just heard me talk about. How do we route people? When should we route? When should we send out the next refill of what beverage to what location? And what other locations are close enough and low enough that it's worth servicing them at the same time? Based on that, we power web and mobile applications that actually control the workflow of the employees and assign them tickets to go do this work. So here again, we've built a completely serverless architecture. And in fact, in this case, truly there are no servers. And we're responsive to the real-time data coming in from these sensors in the field. At the same time, we're powering web and mobile apps with that same back-end infrastructure. So when we're done with this, this is the new workflow now. We look for a dispenser that's low. We look for other dispensers nearby that are going to trip soon. We assign a task. But then also we're able to take the data that we're gathering from these workflows and do analytics and correlate against weather, ticket sales, attendance numbers, and start to make predictions about later today, what the needs might be beverage-wise, but also what the staffing level might be for tomorrow or the day after or even next week, because we know enough about the patterns of people inside these parks on a given day. So here, what we've done is outsourced all of the infrastructure and a majority of the security responsibility to AWS. We get to deliver our business results of a more efficient workforce and cut our operating costs in half. This is not just the cost of the IT I'm talking about, but this is the cost of the whole operation, all the people that it would take to go refill these dispensers is actually half the cost as a result of the solution. And then on top of that, we're getting predictive intelligence. All of this is possible by combining these serverless technologies and the innovative power we get out of the cloud. It can be done infinitely faster than how you would build the same solution on-prem today. So just one slide about Onica. We are an all-in AWS partner. Everything we do every day is help customers adopt AWS better and quicker. So we're all about this kind of cloud-native approach that helps you be the best cloud consumer and treat the cloud as a unique place to deploy to. So we often do get customers talking about, all right, how do I go from what I just heard to building serverless applications? And it's really a three-step process. The first step is to do some kind of enablement workshop where these concepts I've just skimmed over can be dove into much deeper, and then get some hands-on time with your team and have them learn how to build and use these services and get a level of comfort. That removes the mystery, and that's the first step. The second step is to then build a productive workflow. It's really important that we get out of the console and into a normal dev environment when we're working on these projects. So how are we going to develop and test and deploy and promote? Solving that is really important. And it's not that it's particularly challenging, it's just important to do it up front. And then part three is to start actually developing a full stack serverless app and understanding all the other services that you're going to utilize besides just Lambda to accomplish that.
Awesome. Thank you, Tolga, for joining us today and giving us insight into what it is to do or build modern applications on AWS, and especially around serverless. And thank you all for watching and listening today. We really appreciate you giving us your time, and we look forward to finding ways to help you move to the cloud.